Welcome you all today in our today's masterclass, which is lecture 7 of chapter 3, periodic properties of element and chemical bond. We have already discussed many vital topics from this chapter. Today we are going to solve questions from these two topics, which are polarity of covalent bonds and covalent characteristics of ionic compound, and also the less important topic of this chapter, which is nomenclature of inorganic compound. We are going to discuss from polarity of covalent bond because it contains Pajan's rule. Basically, Pajan's rule is applicable for determining covalent characteristics of ionic compound, while on the other hand, instead of Pajan's rule, we will talk about polarity, which will give idea about ionic properties or characteristics of covalent compound. So which one is more ionic, which one is more covalent, such questions will appear, and we have to answer those questions based on these two rules. We'll be discussing more in detail while solving the questions. Okay, and for nomenclature, we will also provide some easy techniques so that you can solve all the questions that are available in your exercise, and also if there is any in your admission test. Okay, as we can see, the last time question appeared from this topic was 21 to 22 session. At that period, it almost came serially in each year. Okay, so this is important, and you all know, as you have appeared HSC exam and also you prepared enough time on this chapter, on this topic, so you should also by this time know that it is easier to make questions from Pajan's rule, right? So we will solve as much as possible, as much as available in your exercise, so that your basic gets clear and you can easily solve if anything comes from them. Which compound is more covalent? This is the first question. See, it is a straightforward question asking about more covalent. More covalency can be asked in numerous ways. Like it can be asked this way: which one shows less melting and boiling point? Okay, again it can be asked in this way: which one is less soluble or insoluble in water? Okay, it can also be asked this way: which one is more stable or less stable on heat? Okay, in this way many questions can be asked. Anyway, this is a straightforward question asking about which compound is more covalent. Now, since all of them are charged, all the anions are same, but all the cations are different. So for determining the more covalent compound, we have to apply Pajan's rule. Pajan's rule dictates three principles, which are: the first one is high charge. High charge. That means for cation and anion, those who possess high charge have the potential to polarize or be polarized. Before going to Pajan's rule, actually we need to clarify what is polarization. When a cation is placed in front of an anion, then they do not stay the same. Because of the smaller charged density with more density of positive charge cation, due to its positive charge, the electron cloud of anion gets distorted. This distortion is called polarization. So what happens? Anion gets polarized because negative ions tend to come towards that direction, and the positive tends to go to the opposite direction because of the density of the charge. So anion gets polarized by cation, not happen otherwise, because cation do not have electron cloud or large electron cloud like anion. So now feel this way: the amount of charge, the more the amount of charge, the more the scope for polarization. If cation is more positively charged, then it will compel the electrons, or it will forcefully pull the electrons towards itself. So there will be more chance of polarization for higher charge of cation, and also higher charge of anion means it got more electrons. So if it has more electrons, then it has more chance to get distorted, right? In this way, first condition is fulfilled. If high charge, then chance of polarization is more. If we look at these options, we may find that calcium is positively charged, magnesium is positively charged, iron is positively charged, and their charge are not equal. Considering all the charges, we have already excluded these two options. Now we are left with these two options. Our answer lies between C and D, and now we have to determine which one is the more appropriate one. Anyway, the next case, we get that size of cation. The next thing, we have to look at the size of ions. For size of ions, we have two different theory. The cation should be smaller and the anion should be larger. Why? Because smaller cations have higher density of positivity, so it gets the higher potential to polarize an ion. On the other hand, if an ion gets larger, I mean, consider a man with a big belly like me. In this case, there's more chance to get a distorted figure if someone is overweight. Similarly, anion is overburdened with electrons, so it is more prone to distortion or polarization. So in this case, cation size and anion size may be considered, but here we can see that chlorides are same for both aluminum chloride and ferric chloride. Now we have to consider the size of aluminum or iron. but you will be surprised to know that the size of aluminium cation and ferric cation is somewhat close to each other. They are very near to each other. You may be wondering why aluminium is only atomic number is 13. Aluminium got an atomic number of 13, while iron got an atomic number of 26. How they will be close to each other? Actually, considering ferric chloride structure, if we consider the structure of iron, then there will be 3 shell. But if we consider the structure of aluminium, there will be 2 shell. So in that case, since they leave the electrons of the outermost shell, in that case their shell also gets decreased. But their size, since aluminium chloride have smaller size, aluminium got smaller size, so aluminium has the more potential to polarize chlorine atom. In terms of size, though these sizes are very close to each other, but I must say aluminium is smaller than iron. But this difference do not matter much here. Here, another condition which is more important to consider according to Fajans rule comes in hand. That condition tells us that you have to look at electrons in d orbital. Electrons in d orbital. If the cations have electrons in their d orbital, then they have the potential to polarize, or they have the higher potential to polarize the anion. So, considering all the 3 conditions, you may wonder, considering the size of cation, aluminum chloride should be answer. Again, considering the electrons in d orbital, ferric chloride should be the answer. What should be the correct answer? If you look up on the website, you will find that aluminum chloride shows lesser melting point than ferric chloride. Still, in our book, considering this logic, ferric chloride is marked as the correct answer because of having electron at the d orbital. Okay, but actually it was supposed to be aluminum chloride. But considering the third condition as the most important condition, the answer given is ferric chloride. So I think after all discussion, you have learned what are the covalent natures, and also you have figured out what is Fajans rule and when to apply what rule. I think it is a good practice for everyone. Which compound is related to polarization? Polarization, actually, you should remember that polarization describes covalent nature of ionic compound. Covalent nature of ionic compound. On the other hand, polarity represents the opposite, which is ionic nature of covalent compound. Okay, so which compound is related to polarization? This is ionic compound. In which compound does the highest polarization occur? That means highest polarization means highest covalent. Which one shows highest covalent nature? In this case, all the anions are same, but for cation these are different, and charges are also not same for every cation. As we can see, option A and C can be correct because they do have high charge and equal. But now comes the term size of the cation. In case of beryllium and magnesium, we all know that beryllium cation is smaller in terms of compared to magnesium. Since beryllium is smaller than magnesium, the answer here will be beryllium chloride. Okay. Now let's move on to the next question. Which molecule is polar? Carbon tetrachloride will not be a polar molecule because at 4 end they have similar atom, which will pull away the electron, as a result nullifying the electron dipole moment. On the other hand, in case of hydrogen iodide, will it be polar? For hydrogen iodide, the difference of electronegativity will come handy here. The difference of electronegativity of a diatomic molecule should be more than 0.5. Should be more than 0.5 for considering that molecule as polar. Iodine do not have iodine and hydrogen. If we differentiate their if we consider the difference of the electronegativity, it will be less than 0.5. That's why it is not going to be polar. Methane is also not polar, but the most obvious option lies at the last option, which is water. Water is highly polar solvent. Which molecule is polar? Again, similar type of question is there. Here both hydrochloric acid and water are polar. Why hydrochloric acid is polar? Because chlorine got a atomic electronegativity of 3 and hydrogen have an electronegativity of 2.1. The difference between them is 0.9, which is sufficient enough to call them polar. Which compound has the lowest melting point or more covalent? Okay, here all the cations are different, all the anions are same. So we have to look for smaller cations. For smaller cation, lithium chloride should be the answer because lithium is the smallest among the other members of group 1. Which of the, not smallest, hydrogen is the smallest, but in that option, in that question, we have the smallest as lithium. Which of the following has the least melting point? Aluminium chloride got the least melting point. Why? Because aluminium shows +3 charge, which is responsible for more polarization as well as more covalent characteristics. What is the melting point of sodium chloride? The melting point of sodium chloride is a general knowledge type question. You have to know that, which is 801 degrees Celsius. Also, you should know that the boiling point of sodium chloride is 1470 degrees Celsius. Which compound has the highest melting point and boiling point? Okay, so we have to consider which one is more ionic. Since it is asking about highest, so we have to determine which one is more ionic. Now, according to Fajans rule, if we calculate the charges, all the charges are same. Now we have to opt for looking for the size. The more the size of the cation, the less will be the polarization. So here we can see calcium, iron, copper, zinc, all are in the same period. As all of them are in the same period, we should think that in a period from, we know that in a period from left to right, the size decreases. So here the largest among all cation is calcium. For that reason, calcium chloride is the answer, because if I write down their order of size according to their size, the correct order should be this way, like calcium is largest, then iron, then copper, and lastly it will be zinc. Okay, which ion can polarize an ion most? The one with the higher charge and the one with d orbit electrons in d orbital. In which compound does the highest polarization occur? Highest polarization will occur in this. Why? Because this cation is smaller cation, smaller and high charged cation. Which ion is less polarized? For an ion to be polarized, an ion needs to be large. The more the anion becomes bigger, the more it gets polarized. So anion size is proportional to polarization. Now we have to determine the smallest anion, which will be less polarized. Here among all these four, the smallest should be fluoride. Which of the following sulfate salt has the least solubility? We have to remember that sulfate and carbonate salt. For sulfate and carbonate salt, solubility decreases downward in a group. On the other hand, hydroxyl or hydroxides shows opposite. For hydroxides, solubility will increase downward, but for carbonate and sulfate, it would go opposite. So in this case, all of them, copper sulfate, sodium sulfate, aluminum sulfate, barium sulfate are not in the same group. So I think these two formula will not come handy here. But considering the polarization fact, we can see aluminum got 3+, barium got 2+, sodium got single positive, copper got single positivity. Now it is asking about which one got the least solubility. In terms of Fajans rule, we may find that aluminum sulfate, as it shows higher charge, so it will be responsible for higher polarization, as well as it will result into less solubility, but this is not the case here. Here, the atom or the compound with least solubility should be the barium sulfate, because it got the bigger size of cation. This one, barium sulfate. Here, actually, the polarization issue will not come. Here, the difference between the cation and anion will be responsible for the laser solubility. So in this case, the answer will be barium sulfate. Though the charge is smaller than aluminum, yet here barium sulfate is the answer, because barium sulfate lies in the bottom portion of the group, and we have already learned that solubility decreases downward. Okay, let's move on to the next question. It's asking which sequence of polarization power of cation in ionic bond is correct. For polarization power, the charge should be higher and the size should be smaller. So here all of them possess the same charge. Now we have to look at their size. Smallest size here, hydrogen ion, then sodium, then potassium. So this will be the correct order. Okay, let's move on to the next question. The next question is asking polarization occurs mostly in which molecule, or which one shows high or more covalent property. Okay, in this case, halogens are different, but here we can see the largest halide will be iodide, and this iodide ion tends to be more polarized. So the answer would be silver iodide. And you will also know that the more the degree of polarization, you should also know that the more the degree of polarization, the more will be the intensity of color. I mean, if silver chloride is light yellow, then silver iodide would be dark yellow, I mean deep yellow. Okay, 16th question asks which compound has the highest covalent characteristic. The compound which shows highest covalent characteristics should have the highest amount of charge, which is aluminum chloride. Which one is nonpolar compound? Carbon tetrachloride is certainly nonpolar compound. Someone might wondering that why am I not calculating the polarity by calculating the difference of their electronegativity. Suppose carbon got an electronegativity of 2.5, chlorine got an electronegativity of 3, so it is 0.5, hence it would be polar. No, this is not the case here because of their relative position. Once you place all the chlorine in 4 hands of carbon, you will see that this chlorine will pull electron away from carbon, and this chlorine will also pull away electron from carbon. I mean, bond electrons will be pulled away by chlorine. These are called dipole moment. So all of them have equal dipole moment acting exactly opposite direction. So one moment will nullify other. As a result, there will be no net dipole moment. That's why we are calling them non-polar. Okay, let's move on to the next question. Which compound is related to polarization? Certainly ionic compound, right? Because ionic compound shows covalent characteristics by being polarized. Which one is the correct order according to boiling point? Okay. This order actually depends on the hydrogen bond. As you can see here, in case of ammonia and in case of hydrogen chloride and in case of water, there will be hydrogen bond. But the strength of hydrogen bond should be higher in case of hydrogen fluoride, and should be though the order actually according to in case of hydrogen chloride, the hydrogen bond will be stronger, but the number of hydrogen bond will be less. On the other hand, in case of water, the chance to form hydrogen bond is more than the rest of the two. One water molecule can bind with 4 different water molecules using hydrogen bond. So that's why we will get higher boiling point for water and lesser boiling point for hydrogen fluoride followed by ammonia and followed by methane. Methane is a gas at room temperature. Ammonia is also a gas in room temperature. On the other hand, hydrogen fluoride and water stays at liquid state. Okay, the correct answer should be D. Which of the following has the lowest melting point? The lowest melting point will be demonstrated by silver iodide because iodine gets more polarized because of its larger size. Which is more soluble in water? Sodium chloride will certainly be more soluble in water because of its higher ionic characteristics, lower covalent characteristics. Which one is correct for polarization power? For polarization power, aluminium certainly will show greater polarization than magnesium, so it is incorrect. Magnesium will not show greater polarization than aluminium, so it is also wrong. Beryllium 2 plus will certainly have the more polarizing capacity or ionic potential than beryllium 2 plus. Why? Because then magnesium 2 plus. Why? Because magnesium is larger than beryllium, hence the charge density will decrease. Here the charge density is more. Now let's move on to the next question. Which compound is more polar? The more polar version will be here. We have to determine it. Which compound is more polar? Okay. For more polar, aluminum chloride is covalent. Aluminum chloride will not be polar. Sodium chloride here the answer. Which compound is more polar? Certainly the answer will be sodium chloride. Magnesium chloride will show more polarization because of its higher charged. More polarization. Carbon tetrachloride will show most polarization. I mean, it is not even an ionic compound. I mean, to prove its covalent characteristics, we do not have to explain it with polarization. Rather, I can clearly state that this is a covalent compound. Rather, we would rather calculate its polarity to determine its ionic nature. So here the only polar compound available here is sodium chloride. Which is correct for the order of polarization power? Okay, the polarization power lies within the cation, but for being polarized, the anion size matters also. When the anion gets larger, then the chance of polarization or chance of being polarized increase. So in that sense, bromide should have the highest chance to get polarized, followed by chloride, followed by fluoride, because this is the order that the size decreases. In this case, the answer will be B. Which one of the following compound has the highest melting point? Highest melting point or higher melting point represent ionic characteristics. So we see that all the cations are same, but the anions are different. In case of anion, we have to look for smaller size, because smaller size of anion will be least polarized, and least polarized molecule should show higher melting point. Here, the answer will be calcium fluoride. Since the fluorine is smaller than rest of the halogens. In fact, smallest halogen is fluorine. Fluoride ion. Okay, which of the following is correct for the order of ionic properties? Which one of the following is correct for the order of ionic properties? Okay, for ionic property, if we go through the first one, we see it is +2, this is +3, this is +1. So this should not be the correct order. Why? Because which one in the cation here is more positively charged, means it is responsible for more polarization. So it will be more covalent. In fact, it will be the most covalent among these three. So let's put it at the leftmost corner, mentioning that it has the least amount of ionic characteristics, followed by the +2 charge, which is magnesium oxide, followed by the +1 charge, which is sodium oxide. So this is the order. This is the order of ionic properties. Which has the lowest dissociation temperature? Okay, carbonate and sulfate. Carbonates basically dissociates on heat, and the degree of dissociation on heat increases downward. So when the size of the cation decreases, the polarization gets increased. The polarization gets increased means the covalent nature gets increased. The covalent nature gets increased means lesser temperature of dissociation. So in that sense, we can easily predict that here the one with higher charge and lesser size will show lowest dissociation temperature. Basically, we determine this with phi. Phi means ionic potential. Ionic potential determines the potential to polarize an anion. So ionic potential is an identity of cation. We determine this with two variables. One is charge, another is size. The more the charge, the more the chance to polarize an ion. The less the size, the more the chance to polarize an anion. Which one of the following has the highest boiling point? In this case, the highest boiling point will be for ammonia. Why? Because here, as we can see, hydrogen bonding is possible, but on the other options, there is no possibility of hydrogen bonding. Which compound has more polarization power? Which compound has more polarization power? To determine the more polarization power, first we have to calculate the charges. Yeah, here we can see calcium and magnesium both have +2 charge, but which one is larger, magnesium or calcium? Calcium. So calcium cannot be the answer here because they are asking for more polarization power. More polarization power will be demonstrated by the highly charged smaller cation. So the answer would be magnesium chloride. Which one of the following compound has the highest melting point? In this case, the highest melting point will be demonstrated by the smallest anion. Why? Because smallest anion would be least polarized. Which salt of the following gets dissolved in water? The water solubility increases in ionic nature, decreases in covalent nature. Now, all of them are halides of silver, but smaller halide is fluoride. In this case, the silver fluoride compound shows higher ionic characteristics than rest of the options. That's why it will be soluble in water. Which compound is insoluble in water? The water insoluble compound will be calcium fluoride. Why? Because it shows more polarization because of its high charge and smaller size. Okay. In which compound does maximum polarization occur? Maximum polarization will occur in case of high charged cation, small size cation. Now look at this. The highest charge is visible in lead chloride. So the answer here will be D. Between calcium chloride and aluminum chloride, which one is more covalent? It is very easy question. Since aluminum got higher charge, it will certainly show more covalent nature than calcium chloride. So the answer will be B. 4 elements A, B, C, D with atomic numbers serially 11, 12, 13, and 14 respectively form compounds with X. Okay, so I can write down this way. X has an atomic number of 17, which is chlorine. So the compounds here are sodium chloride, magnesium chloride, aluminium chloride, and silicon tetrachloride, right? Out of these 4 options, which of these compounds is more covalent? Certainly the one with higher charge. Okay, the answer will be D. Which compound is more ionic? To become more ionic, the cation should be larger. To become more covalent, the cation should be smaller. So here the largest cation will be rubidium. So rubidium chloride will be more ionic. Which of the following compound has the highest polarization power of metal? Highest polarization will be for the smaller, highly charged cation. Smaller, highly charged cation, which is magnesium here. Which of the following is easily soluble in water? Easily soluble in water would be ammonia because of its hydrogen bonding capability. Which of the following will polarize anion the most? It will be D. Which of the following is the correct order of thermal dissociation? Since polarization increases with decrease of cation size, so we can say that the smallest cations like beryllium carbonate, magnesium carbonate, beryllium carbonate will be least stable on heat, followed by magnesium carbonate, followed by calcium carbonate. So barium carbonate in fact will be more stable on heat. It will be more stable on heat and it will be least stable on heat. In this case, the answer will be B. In terms of dissociation, the order will be this. In terms of stability, the order will be opposite. Okay, which one is insoluble in water? Calcium carbonate is certainly insoluble in water, but basically if it is asked in the opposite direction, like which one is soluble in water, then the answer will be lead nitrate. Calcium carbonate, zinc carbonate, all of them are insoluble in water, but here better answer is calcium carbonate. But if it is asking this way, which one is soluble in water, in that case the better answer will be lead nitrate. In which of the following compounds does the least polarization takes place? Least polarization will be takes place in the low charged version. Here we can see these are the low charged, but this is high charged. So higher polarization will be there for C and D. Now among A and B, or between A and B, which one will be the correct answer? The anion gets larger in option B, so it tends to be more polarized than the fluoride. The answer will be A here. Why? Because it will show least polarization. Which one of the following ions will form the most soluble hydroxide? The most soluble hydroxide will be potassium. Okay. Which one of the, why it is the most soluble hydroxide? Because solubility will decrease if the cation charge gets higher, and solubility will decrease downward. So potassium lies above. Actually here that consideration of group will not come handy. Here the thing will be applied is Poisson's rule. Poisson's rule stating that high charge means high polarization. So least polarization would result into most solubility in water, which is A, option A. 45. Which one of the following is non-polar? Boron trifluoride is non-polar. Why? Because as you can see, in case of phosphine, there is a lone pair of electron. In case of chloroform is also a bit polar. Though it is a non-polar solvent, yet it shows a degree of polarity because of the asymmetrical structure. Why asymmetrical? Because at all sides there is no chlorine. At one side there is hydrogen. Because of this asymmetry, there is some net dipole moment, which is responsible for its polarity. The only atom here, only molecule here where no such thing called lone pair electron is present is boron trifluoride. That's why it lacks the chance to be polar. Which one is the correct order of increasing covalent characteristics? Covalent characteristics will increase according to their charge. So in this case, highest covalent character would be shown by beryllium chloride, followed by lithium chloride, followed by sodium chloride. Why lithium chloride is in the middle? Because it is smaller than sodium. Which one of the following ions has the highest polar charge density and polarization power? Certainly it would be lithium because of its smaller size. Which compound has a dipole moment? Dipole moment would be applicable for CH2Cl2. Why? Let me explain. Suppose this one is hydrogen, this one is chlorine, this one is hydrogen, this one is chlorine. So let's see. Chlorine pulls away electron and hydrogen gives away electron. Chlorine pulls away electron, hydrogen gives away electron. In this way, we can see that we have a resultant vector in this direction. That is, it has a net dipole moment. But for the other options, all are symmetrical in shape. For symmetrical shape, there will be no dipole moment or net dipole moment. Which is the most covalent in nature? Most covalent in nature will be beryllium carbonate because of its smaller size of cation. Which of the following dissociates at lowest temperature? Lowest temperature dissociation will be showed by magnesium carbonate because of its high charge and smaller size. At what condition? What are the conditions called? Those determine the degree of polarization. These are called Poisson's rule. Which of the following is not Poisson's law of polarization? Cation has more charge, anion has less charge. No, anion should also have higher charge to be polarized. Which of the following compounds is soluble in water? As I have already mentioned that sulfate shows higher solubility in descending order or in a group. These are not members of same group, so forget about that. But let's consider about their charges. If we consider their charges, it will be +2. It will be +2. It will also be to some extent. It will be +3. Not +3, +2 as well. But I think this formula is incorrect. But here, the more the charge, the more the polarization, so it will be less soluble. Here it is asking about the solubility of water. The more soluble version is sodium sulfate. Again, I want to mention that all sulfates are water soluble except castrobier. Castrobier. That means barium. I mean calcium sulfate, strontium sulfate, barium sulfate. These are not water soluble. Moreover, lead, mercury, and silver. So lead sulfate, mercuric sulfate, and silver sulfate. Okay. With this, I would like to mention that sodium sulfate would show higher solubility in water. The correct order of solubility of beryllium sulfate, magnesium sulfate, calcium sulfate, and barium sulfate will be, as I have said, sulfate would show decreasing solubility in the descending order. In that case, least soluble would be barium sulfate. So the answer will be this. The order of solubility can be presented this way. Beryllium sulfate will be most soluble, and the barium sulfate will be least soluble. Which of the following compounds has the highest solubility? Yes, in that case, or in this case, the answer will be magnesium sulfate, because the position of magnesium is above, in the upper zone of this group. Which one has the highest boiling point? For highest boiling point, we may have to consider the chance of hydrogen bond formation. Here we can see all of them have the potential to form hydrogen bond, but now we have to consider the number at which they can bond with another hydrogen through van der Waals force, I mean dipole-dipole interaction. In this case, as we can see, ethanoic acid can form easily a dimer. That's why ethanoic acid shows higher chance of forming hydrogen bond, as a result, highest boiling point. Intermolecular force depends on which of the following factor? Intermolecular force depends on polarity. Intermolecular force depends on certainly polarity, because the polarity is responsible for the partial positivity and partial negativity. That's why the intermolecular force compel them to stay close. Okay, now we are going to discuss, or we're going to solve questions from a bit less important topic, which is nomenclature of inorganic compound. We found a question from this topic last on 16-17 session. Anyway, as it is in our book, we have to solve it. Which one is called pyroacid? Okay, the nomenclature of acids can be demonstrated this way: hypoas, as, ic, par. This way. Okay, if the central atom oxidation number becomes +7, if the central atom oxidation number becomes +6, if the central atom oxidation number becomes +3 or 4, or below that, in that order, the name of the acid gets changed. Anyway, here, as we can see, this is perchloric acid, not pyroacid. This is perchloric acid. This one is phosphorus acid. Phosphorus acid. Why it is phosphorus? Because it shows +3 charge of the central atom. Here we are observing +6, which is responsible for the name sulfuric acid. Sulfuric acid. I'm just marking the title in different color. The suffix that was added here because of their oxidation number. Anyway, the last one is also known as oleum, which is actually pyrosulfuric acid. This one is the correct answer here. Which of the following acid is a hypoacid? Okay, here phosphorus acid shows +3 charge. Here the charge of phosphorus, I mean the oxidation number of phosphorus, becomes +1, right? Since the value gets decreased from the as version, so it will be the hypoas version. So it is hypoas phosphoric acid, and the remaining one, we know that this one is phosphoric acid and this one is metaphosphoric acid. If the chemical name of the central atom of oxy acid contains ic at the end, instead of that name, the salt becomes it. For us, it becomes it. For ic, it becomes it. Which is the formula of calcium phosphide? So this is certainly this one. What is the formula of bauxite? This is also important. This one is bauxite, this one is gypsite. Which is ite compounds? Sodium stannate, sodium potassium carbonate, potassium chlorate, sodium plumbate. Since it got 2 oxygen, this will certainly be it. What is the oxidation number of chlorine in perchloric acid? We have already considered or calculated this, which is +7. Oxidation state of silicon. Here, if you try to determine the oxidation state of silicon according to the traditional approach, you will find that the oxidation number will come out wrong. Suppose this is +6, +x, this is +2, this is -2, and -6. So eventually, you will get the oxidation number as 8 - 2, which is +6, but this one is totally wrong. Why? Silicon do not have that potential to show a higher oxidation state than +4, because it lacks that opportunity. Okay, so in this case, the oxidation state will be 4, not 6. Silicon shows the highest valency of 4. Because of that structure, it can only show +4 as its highest oxidation state. Which of the formula for perchlorate ion? For perchlorate ion, the formula will be B, which is hypochlorite. Hypochlorite will be this one. Hypochlorite. How am I determining this? We can determine this using the oxidation state. Okay, as I can see, this one is perchlorate, this one is only chlorate, this one is chlorite, and this one is hypochlorite. Okay, hypochlorite. Which one is correct for intensity of oxo acid? To determine the strength of oxy acid, we have to consider the central atom oxidation number. The more the oxidation number, the more the strength. But it does not applicable for phosphorus and phosphoric acid. You will be wondering which one is stronger, H3PO3 or H3PO4. You may find that phosphoric acid shows the higher oxidation state, so it will be stronger. No, you are wrong. The strength of phosphorus acid is more than phosphoric acid. Anyway, this is not the situation here. Here we have to just calculate the central atom oxidation number of these three, which is +5. Here we can see +3, and here we can see what? Which one is correct? This one is +1, right? -2 +1, so it will be +1. Again, here we can see +5. I think this order is correct. The first one is already correct. Okay, 5, 3, 1. The order is perfect. So we can mark this one as the correct answer. Which one is correct for intensity of hydrohalic acid? Hydrohalic acid should be B. Hydrogen iodide, hydrogen bromide, hydrogen chloride, hydrogen fluoride. Why? Because we know the more the size of anion becomes, the more the distance with hydrogen ion. So hydrogen ion tends to be dissociated easily. As a result, strength of hydrogen iodide gets increased because it has the more potential to dissociate hydrogen ion. So with this, our questions regarding these two topics, that means polarity and polarization, as well as the nomenclature of inorganic compound, came to an end. Practice more to do better in the exam. Best of luck.